So I want to find the volume of a solid here, and I need to use triple integrals. And the region is in the first octet. It's formed when the cylinder that's given by z equals sine y, for y goes from 0 to pi, is sliced by the planes y equals x and x equals 0. This would help if we could draw a picture of this thing. Now, I've got y going from 0 to pi. So y is going to come out here to pi. And z is the cylinder sine y. So when z is 0, sine is 0. So it's basically going to be something like this. So picture a cylinder. If I were to draw this like this, half a cylinder, essentially. You kind of see it going like that. I know it's a half a cylinder because I have z equals sine y, and y goes from 0 to pi. So I know it's this half cylinder looking thing. And it goes on to infinity. Except I'm going to slice it by the planes y equals x. Well, y equals x, I can write that. That's just a line. So if I think of this as a plane, it's going to slice this thing. So this is going to be gone, but it's still cylindrical. And x equals 0. X equals 0 is the y-axis, so it'd stop here at the y-axis. So basically, it's this almost cone sort of a shape thing. Now, to see if I can give you a little bit better picture of what's going on, let's take a look at Mathematica. Here's some code that I used. The plot 3D is just to get that cylinder going, and then the contour plot 3D is get the two planes in there. So let's take a look at what we get. And let me spin this a little bit because the axes aren't labeled very well. That should look a little bit more familiar to you. Whoops. There we go. That should look a little bit more familiar to you. See, this is the line y equals x with the plane y equals x, x equals 0. And there's that cone sort of a thing that I was talking about. Basically, all of this would not exist. And this piece here is what I'm actually trying to integrate over. Okay, so now we need to think in terms of how we're going to set up these bounds to integrate. First of all, obviously I need a triple integral. And I can change the order of these bounds if I want to later. I know that I'm going to go from the xy axis, z equals 0, up to this surface. And this surface is sine y. So I know that z is going to be going from 0 to sine y. And then I can look at this a couple of different ways. If I think in terms of what y is doing, so I can do dy, y is going for the line y equals x up to pi. So I can think of y as going from x to pi. And then one of the things I need to worry about or think about is the coordinates of this line, right? Or coordinates of that point right there. Well, this is the line y equals x, y goes to pi. So this point must have coordinates x is pi, y is pi, z is 0. So x must go from 0 to pi. Now I want the volume of this region, and as you may recall, to find the volume of a triple integral of a volume in 3 space, the integrand is just 1. So this is what I need to integrate. And actually, I think I'm satisfied with the order I happen to write it down, so I'm just going to go ahead and start working with it. So this just could be z evaluated from 0 to sine y, which is just simply sine y. So this is going to be a negative of, I'm going to pull this negative out here, cosine of pi, which is a -1, minus cosine of x. So I'm going to have cosine x plus 1. And this last integral was from 0 to pi. Cosine x plus 1 dx, which is sine x plus x from 0 to pi, which sine of pi and sine of 0 are both zeros. So I'm going to end up with simply pi.